Okay.
Okay, so you actually have two controls on this machine. This is the standard control that comes with the Accupress. It's called the RC1, and this controls only the ram up and down. Then this AutoMech control can take over for the ram and can program the ram and the back gauge in and out. So early on, when press brake manufacturers first started, a lot of them didn't build their own back gauge and their own CNC system, so they had a retrofit put onto it after the fact, and that's what this is. This was right around the split when Accupress started to build their own back gauging and control system. So the first thing we have to do is calibrate the Accupress ram control, the RC1, or the ram won't move at all. Then we'll have to double that up again and calibrate again with the AutoMech control in order to use the AutoMech control. So the first thing to do is twist the red start button until the e-stop pops up, and then hit the start button to start the hydraulic pumps. And then we're kind of worn out here, but the first thing that it wants us to do is calibrate. You can't really see the calibrate in there, but it does say calibrate behind there, or kind of abbreviated, and then we get all zeros here. So in order to calibrate the ram, we have to be all the way up at the top of the stroke, and we have to, kind of like an ignition key in the car, you got to turn the ram control on. So when the ram control is on, come all the way up to the top. It'll stop when it hits that, and we still have the calibrate equals 0, 0, 0. And now when I hit the flip switch, we'll grab the flip switch here. The ram will jog off the top about 1/4 of an inch, and then that's it. That's all you have to do to calibrate. But that's the Accupress side. So now the Accupress is ready to run, and we could use the ram control here. Since you have this nice upgrade to the system, it's probably best we just go ahead and calibrate and run the ram through the AutoMech. So the AutoMech is kind of clunky with the key switches or the keystrokes that you have to perform, so they put up this little sticker here, and that's pretty much what I do every time I run into an AutoMech, like once every year, is I refer right to this quick reference guide. So the first thing we want to do is to calibrate the back gauge. So we have to go through all of these keystrokes. Press flange, then bend, 0, minus. So I'll do that. Flange, bend, 0, and minus. And then manual and advance. And the gauge will go all the way back to 24 inches and then come into this 2-inch calibration. We'll hit manual, advance. Oh, that didn't work out very well for us.
Advance is not good.
Oh, okay. So we'll have to do that again. Flange, bend, 0, minus, manual, advance. Well, I guess it was already calibrated, or it knew where it was. Normally, if I shut it completely off, up to 2 inches. Then, to select the ram mode where applicable, we can press bend, 0, minus, and then depth, and it shows up here as a position. I'm going to teach you guys how to use it in position mode. You can tell the AutoMech how wide this V opening is, and then in theory you can program in an angle, and it should give you an angle that's pretty close. The reason that I feel more comfortable with position mode is because it's very theoretical, that angle, and the position mode is going to get you where you want to go a lot faster. Plus, making angle corrections is kind of much easier.
Yeah, you just look at bend, your job, and your flange and all your depth, right?
Yeah, and then tap your depth a little bit. So we're going to need to calibrate the ram. So to calibrate the ram, we're going to press depth, bend, 0, minus, and then manual again. But we have to have some material in
Yeah,
it.
I got a piece right here. This is the thickness we're going to be bending. So.
Okay, that's perfect.
Let me get mine in here.
Every time we calibrate the ram through the AutoMech, we need to have the tools we're using for the job and the material thickness. because we're calibrating it. Basically, we're going to tell it where the top of the material is. So I'll start over again. We're going to press the depth, bend, 0, minus, and it tells us on here that we'll get this -100. Then we'll press advance. And now, important is on the ram control, we'll need to put it in jog. Yeah, so the ram stays where we put it. If we are in auto or manual, it'll pop up every time I let off the foot switch. That's how it works. So I'm just going to close all the air out of that. And now we're nice and pinched on the material, but it's not bent yet. And then, let's see, advance. And now from here, when we come up, we should be counting in a negative number. Let's see. Nope. Let's calibrate the ram, press bend, depth, bend, 0, minus, manual.
And then now you touch the top.
Okay, and then advance. There we go. Now I got a negative number up here, and as we come up, it counts. So everything from the point that you pinch the material upwards is a negative number, and everything you're going down into the material is a positive number. So here we only have about a 1/2 inch of total depth from the top of the die to the bottom of the die. So on our way down for our bend, we should never have a number that's bigger than 1/2 inch. And then what is that, 135? You don't have to measure, but just a pop.
Yeah, it's close.
Let's say it's 100 thousandths. So really, we shouldn't have any number that's bigger than 400 thousandths down, because by then we're smashing the material into the die.
Yeah, crushing the dies.
Yeah.
Which is no good.
Right. So to set up a job, you have a total of 99 jobs. That's where they get the CNC 99 here. If I press job, we'll go to job 003. Job 03. We'll set up job 03. Bend number 1. Right now our flange is highlighted with the LED here. So our bend number 1 back gauge dimension is 2 inches and 30 thousandths. So let's say I wanted that to be 5 inches. Bend 03, flange 05. So then bend 01, flange 5000. So that'll be our back gauge dimension. The next one is ram depth is 2.86 or 0.286. So that's about halfway through our V. I'm not exactly sure where that's going to need to be yet. We'll have to take a test bend and see where we come out. And then we'll raise and lower that appropriately. And I'll kind of tell you explain how many thousandths of an inch is 1 degree and change. Roughly with this die combo, 4 or 5 thousandths in change on this ram depth is going to be 1 degree. So if we're 10 degrees underbent, we'll add 50 thousandths. If we're 10 degrees overbent, we'll subtract 50 thousandths, and then we should be pretty close. This next one, ram height of -3. After we finish this bend, it's going to come up 3 inches.
So that's where it stops, right above the metal?
That's where it stops, pretty much ready for the next bend. So if you're doing 500 of this little 1/2 inch bend,
Yeah, you don't want it to come all the way
you don't want it to come all the way up to 3 inches. That'll wear you out all day long. And you're just going to waste time watching the ram run up and down. So is this the part?
Yeah, this is what we're trying to get right here.
Okay. So
I actually got the bend to go. What was actually happening is the machine was running half the speed it normally ran at. The guy I was talking to said it may be in like an anti-whip mode. Or where the slow speed is engaging. That's what I was trying to figure out is how to do that.
I could fix that for you. I actually changed it already, but I'll show you what happened.
Okay.
So what's the outside or the bend line for
This
this?
is a 1/4 inch bend and it's supposed to be at a 90. So I think this one was actually under bent. Yeah, this one was under bent, but this one was pretty good. And I think the number I got was like a 285, 0.285.
To give you, that was your bend line?
90, yeah.
Oh, do you remember what your bend line was though, where the back H dimension was to give you a quarter?
1 inch. 1 inch down. So that's our flange depth to get this. So when this came down, it was an inch, and you just touch it on the front one.
Okay. And it was 1 inch.
Yeah, the flange is 1 inch.
Okay. So we'll do the real job. We'll go job 03, bend number 1, flange at 1 inch. And then our ram depth, you said was 285?
Yeah, 280. Yeah, 280 or 285. Try 280 first, just to be safe.
Yeah, let's start even lower. We'll go 270. And then our height, we're gonna go probably 1 inch. Will be plenty to get us out of there.
Right. Yep.
And then if that's still too much, we can change that.
Yeah, I was doing like 1.5 inches, was like perfect.
Okay. And then to set the slow speed, so you have, again, the 2 ram controls, and sometimes they fight against each other. So you have a ram control here for a slow bending speed. And if this one is set, if this one is set here, it's going to override the automatic. Okay. So it's going to start in slow bending speed way up here.
See, that's what it was doing. It was starting it way up there.
So all I did is to run this control as I tap the slow, and again, you can't really see it, but it says adjust slow.
Yep, I can see, yep.
And then I hit these 2 numbers fast, and I ran the slow down a lot further. So it won't come into play before the automac does. Then, to set the slow speed, press bend 0. And I have this set right now at 0.4, so like a ½ inch, not quite a ½ inch above the piece.
Right.
And before we actually put our part in, we can test it and see if we like it.
Yeah, because that's where, the last time I was doing these pieces, that's where it's coming in. It'd go all the way down, and then slow speed about a ½ inch above the piece, and then it would do the bend.
Yep, that's perfect.
But also when it was doing the bend, it was going through the slow speed, and then I think the guy said it was anti-whip, so it touched the piece, the machine would wind up, and then it would do a really slow bend. So instead of just doing a normal bend.
I think I might have gotten that solved. That might have been a mechanical or electrical issue.
Yeah, that's what the guy was saying that I was talking about.
I swapped some relays around.
Awesome.
So we're gonna go bend number. We got 2 of those bends, right? So
actually, it's the same bend, so you could just do it in one job. You just flip the piece.
Bend job 03. Bend 01 is 1 inch. Then what we have to do to finish this job so that it doesn't go there is no save key really in the automech. So as you start to override things, they just overwrite the last job. I don't know if there might be 10 steps in the original job 3, might be 15 steps in there. So if we hit bend 02 and then 0 everything out, flange 0, 0, 0, depth 0, 0, 0, and height 0, 0, 0. That signifies to the automech that this is only a 1 bend job.
Right.
Then if we go back to bend 01, there's our 1 inch height that we're going to come up to. Our total depth of 270. Our flange is set at 2 inches. And now if I hit auto advance, it should start to execute that step. It's going to go all the way back and calibrate, and then it should come into 1 inch. 9.999.
Yeah, it's because it's calibrated, so.
Yep. And now we can see how that does.
Yeah, I'm just making a video, is all.
So now it should slow bending.
That's way better, yeah. That's it right there. Lower your jog butt still. Yeah, we're still a little under, so.
Okay. So we're still a little under to fix that.
Go to bend or
Yeah.
job one.
Let him do it.
Then we hit depth. And now we'll try two. How many degrees are you under? About 5?
Yeah, 5.
So we'll go slow, and we'll say 280. And then to execute and get the job running is auto advance. This must have a retract in it.
That way it does it all the time.
Yeah. Let's try it again. And you can go ahead and hit that one again or try a fresh one.
I'd say we're about 5 under still.
Still need some more.
Yeah.
Let me see what the retract is set at. 2 seconds. We'll make that 0 seconds. Step. Let's go 290. 290. Auto advance. Yeah. See, this time it didn't go back and do its retract.
Closer. Still a tad bit under.
Yeah. We might not be able to. Have you run this job with this punch and die combo before?
I'm pretty sure this is the die combo we use. Otherwise, excuse me, Rich. This would be the only other bottom die we have.
Is it a little bit wider?
I think so.
It is,
Yeah, because you want the wider one for the thicker steel.
Because there'll come a time when we're pushing so hard that we're not able to
Right, that's what the cells are doing now.
Back on.
What about the same?
Quick.
That would be in between here, 10 and 11 gauge. Let's just go with 11. So if we take this 11 and we bring it over across to the diagonal orange line and then go up, we really should have a 1-inch V opening for this material. That's the industry recommended standard. And this 7.4 means it's going to take 7.4 tons for every foot. So what are these, 36 inches-ish?
Yeah, 31.
Okay, so we should have 20, it should only take us 20 tons to bend this. And if we cheat it down, and they said that was 11/16 the V opening.
Yeah.
So we're right in between here. It's gonna take somewhere around 12 tons. Let's kind of split the difference between these two because we're right here with our V opening. 12 tons per foot times 3.5 feet. We should only be 45 tons. So we should be able to do it. Even though it's not, even though we're cheating a little bit. Now if you cheat too badly when you get into this area here, then you shouldn't try it because the material doesn't have enough room in the die. Like you can't bend this material in a 1/4-inch die because it wouldn't have enough.
Right, and don't go far
Yeah.
down, right.
Doesn't go far enough down.
You'd end up with like a little bevel or something.
Yeah. So we can try to hit it down a little bit harder and see if we can get there. So we'll go depth and we'll go 300 thousandths. Auto advance. Give it a try. That's it? Yeah.
Write it on the machine. You know what I mean?
Well, it'll change with the different steel too, because this is
Yeah,
mountain
but-
as the other steel usually gets softer.
Yeah, but I'm just saying that we know that for these braces, that's what you're gonna have to set it at to get it to bend a 90.
Just in case.
So we can look at on the AutoMech whatever we want to watch at that time. So right now, because we have the depth highlighted, it's showing us the depth. And right now we're 1 inch and 0.29 above that pinch point we set when we calibrated. And then we can look at, if we look at our flange, our back gauge is set at 1 inch. And we can watch just the back gauge if we want. Now it'll just keep an eyeball on the back gauge, and that's what will be displayed up here. And it'll stay at 1 inch and won't do anything. And then if we put it back over to depth, now it'll
Watch it.
yeah, as we're running, we'll go ahead and run one dry. Or
Yeah, oh yeah, I'll do a dry one.
yeah, now it'll run through our depth.
Yeah, that's usually the mode I keep it in when we're bending, so.
Yeah, so you can see where you're at.
Watch the numbers. That's it, man. That's our piece. And it's out of slow-mo, so. For the anti.
Yeah, we could probably even lower the height.
Yeah, lower the height.
We could put that at
Half inch.
even 7. Oh yeah, clear. And it won't come up as high, and you can get through a little faster.
That's good because I can still see the little feet in there, so.
Yeah.
It's slightly underbent, but it'll work.
Yeah, it's just back gauge or just back braces anyway. Yep.
Oh, are those cross ribbing for like
They're pool bracing. They're our back braces for the pool.
Yeah, they get bolted together like that, so this really doesn't have to be a perfect 90, so just using it for strength basically. Okay, can you shut it completely down and then restart it back up for me again?
how about if I shut it down completely? And I'm sorry, I'm horrible with names.
CJ?
Charlie. Yeah, I'll do it.
Yeah, Charlie.
Yeah, let's do that, yeah.
Okay, so I like to kill the hydraulics before killing the main power. And this time I'll unplug the AutoMech too.
Here's your big test, CJ.
Okay.
Start.
And then you'll have to calibrate here first. So turn the RAM control on. Now there really should be a light right here to tell you it's on, and the bulb's probably just burnt out. I'll show you how to pull those out and get another one. Granger's got them. So now just hit, it should say 000 calibrate.
Calibrate.
And the key is you have to be all the way up, which you are.
Yep.
Just hit the foot pedal and
And then it comes down to
to
1/4 inch.
So until you've done that, doesn't matter what you've done with the AutoMech, it won't let the RAM run up and down.
And now we're ready to do our flange.
Yeah.
Gotcha.
So then do the back gauge.
Back gauge is flange, then 0 minus, and then max.
And it goes all the way back to 25. before, and then it'll come back into that 2-inch that is displayed right before you hit manual advance.
Okay, so we're good there now. Now
Yep.
we do.
You don't have to do that one.
Because we
That's
already
just
did that.
changing your mode of how you're viewing your RAM depth
Right.
in the AutoMech. You have to do the second one down to calibrate the
RAM.
RAM.
So it's depth and 0 minus. Jump.
Go slow now.
So after you get it in, calibrate, we'll hit advanced, and then everything should go to 0. We should read negative number. So now we hit our RAM up,
Or you can go to auto.
or auto.
On the machine.
Oh yeah, that's right. So
And as long as you see numbers counting here, then it's got calibrated.
right.
And you should be able to take a tape now and go from the tip of the punch to there, and that should be 4.5 inches.
Sorry, Mike.
Right on the money. 4.5.
And now press job. And it automatically pulled up job 3 that,
That
we
was
were
our last
in.
job.
Yep. And if you want to look at it, then bend 0.1. And that's 1-inch flange. And then press the depth, and it'll show you the depth that we have for it.
300.
And then height is how far we're going to come up when we're done bending.
Okay.
And then if you wanted to add another bend, you just hit bend. And then 0.2.
Yeah, you're okay.
Yeah. Then you could push flange. Put that at 1 inch. Depth. 300 thousandths.
Height
Yep. Height.
was, what did we put it at, 1/2 inch?
Yeah, 1/2 inch. And then bend 0.3 and 0 everything out. So the flange 0, the ram depth 0, and the height 0. And then that signifies to the AutoMech that that's the end of that job number 3. And then push bend 0.1, auto advance. And away she goes. So I'm going to try to get rid of that pause for you. I think that's a situation that we can get rid of.
Oh, it was reading
Doing
back.
the replay. Get rid of that. Press bend 0.1. 0.1. Retract. 0. Okay, try bend 0.2. Oh, there it is. And then 0 that out.
and then bend 1 again.
Yeah, bend 0.1. And then it's just displaying the retract.
Yeah, so
So if you want to see depth again,
yeah, depth.
yeah,
Auto advance.
Auto advance.
Cool.
After running this for a little while, that auto advance is going to become second nature. Usually those keys are all worn out on these.
Yeah, when I used to watch the guy who did this, he would hit those all the time.
Yeah.
And he did it so fast, I was trying to watch his sequence.
Right. Yeah, because he's done it for so many years.
Right, some of it I figured out, and then when I opened the book, I started figuring out what he was hitting and everything. So
Well, we still got a retract in there.
it'd be the third one we did.
1, 0, 3, retract 0, then 0, 1, retract 0, then 0, 2. Oh,
Oh, it must not have saved it.
Got a few of those to run, do you?
Yeah, just a few. That's why I was trying to get out of the slow speed. We're not here for a week bending these. Why does it make the grunt?
Well, I think there's something wrong with it. So on the way down, when it hesitates in the part, I think the ram's free falling, and that's a quick mechanical adjustment.
Yeah, that looks really good.
And then I could look at some of the relays more to see if you got some more relays that are burnt up, because it also shouldn't go slow on the way through up either.
Right, it should do fast speed all the way
As
up.
soon as it hits the bottom, it should come fast all the way up.
What's your name?
Paul.
Paul?
Yep.
What's your last name?
Munn, M-U-N-N.
Okay.
I'll give you guys my card too, so that you'll have a card. Email, cell phones on there.
Great.
Munn, M-U-N-N. So it's kind of hard to see because the display is so wiped out. I'll try to get the, right now, if I wanted to create a job here, high is how high you want to go.
Go ahead and shut your light off. I can get it with
Okay.
this if that's out. You can get all the top on, see?
That's where I want to return when I'm done with the stroke. Slow is where I want to go into the slow speed, and then bend is the bottom of the stroke. And it really sucks that it's wiped out here because that's where we're looking at our numbers.
That's 108. If you go like this, you can see it.
Yeah.
It's just, it sucks that it's like that. It looks like it's
So this control, I'll bring it all the way up, and we'll look at our high. What does it say?
403,
No, yeah, no, it's
90.
It's 100.403.
Okay, so I could adjust that number by adding or subtracting, and the way that this scale works is 0 is the top of the stroke, and you just keep building down. So 1 inch is 1 inch below this would be 4 inches, and then the bottom on this particular bend would be somewhere around 5 inches or 4.8 or something like that. And how I would do that is put us in jog and go ahead and run the ram down a little bit. Okay, hold that. Now we're at 1.527. If I hold the high key, that number will flash, and when it's done flashing, it's stored it, kind of like a radio station in a car. So that's our new top of stroke, that physical. Now run it down till you're about 1/4 inch above the material. Doesn't have to, just eyeball it. Let's say there. Then you hold the slow key down until that 4.567 is done flashing. And that's our new slow bend. Yeah, now that just is gonna overwrite
What we had in there.
yeah. And then jog into the punch and die a little bit. And let's say right there is a good 90 for us. Then you can hold the bend down until that number is done flashing, and that's our new bottom of stroke.
Okay, so it's set the top, where we're just kind of slow speed, and then the bottom of our bend.
Yeah.
What's that?
And you could leave the depths and the heights on the automech all at 0, and then the automech won't respect any of the heights for the ram, and it'll just run the back H back and forth. And then you could use this control. And you see this down limit came on? That's because right now we're at the bottom of where we told that we want the bottom of stroke to be.
Okay.
If you see this light coming on before you reach where you want on the automech, and you're increasing on the automech, but this light comes on before it hits that bottom, this is taking over.
I got you.
So what we want to do now is take those values and run them out of the range. So we'll take the high, and we'll just run the high, go all the way up, and hold the high till it's done flashing. We'll tap the bend, and the bend was at whatever, 4.8, and I'm going to hit fast and plus at the same time, and it'll just kind of scroll that out of the way. And then we'll take the slow and do the same thing, fast and just put that at some arbitrary number down here that it can never get to, and the automech will take over.
Okay, I got you. So basically what's going on is I was in a sequence where it was fighting itself. That's why it was going in and out of the slope.
Yeah.
Engaging was slowed up here because this was reading it first before this was.
You got it.
I got it.
Yep, you got it, exactly. And that's kind of the clunkiness of putting somebody else's control onto somebody else's press brake. But it wasn't until maybe the mid-90s that press brake manufacturers made their own back gauges and their controls. Before that, it was a lot of mechanical press brakes, and they didn't have any sophistication to it. You're setting it at 1 inch.
Right.
But really, you should be able to set that at like 400 thousandths. Is about right. That's why I was asking you earlier if you knew what the bend line was. So the bend line is not necessarily what's going to be the outside dimension.
Right, because that's sweet. So
Yeah,
it's
you
always
got-
bigger than the
You got to add the thickness of the metal to it.
Thickness of the metal, and then the bend allowance, how much material gets consumed in the radius. And then when you said 1/4 inch, that's inside dimension, right? Yeah. So to give us the inside dimension, we really need an outside dimension of like 400 thousandths-ish. So that's really what the back gauge should be reading now, 400 or 500 thousandths, as opposed to the 1 inch. So we can fix that, and I should be able to help you with this ram problem too, at least on the way down. Because when it comes and hits the metal and hesitates, and then starts to bend through, what that's telling me is the ram is free falling on the way down. And these guides on the side, they're like brake pads on a car. And here's the brake dust that's accumulated over the years. And there's little pads in here, and they've worn out enough so the ram is just falling down, and then it contacts the material, and it takes a second for the pump to catch up. And then finally it bends through.
That's why it's getting that grunt noise.
That and the grunt noise is a flow divider. So I think we have two problems, and I'm hoping that that second flow divider problem is electrical and not hydraulic. Because the flow divider on this machine, the hydraulic component, is obsolete.
That's awesome.
Yeah. All right, a couple more things on this control here too. So we have hand or foot. We have palm buttons underneath here. If you wanted to use the palm buttons, if OSHA walks in here and they're like, hey, how do you safeguard this thing? You can tell them, well, we put it into hand and we pull the key, and now it can only be run with the palm button. Which still works. Yeah, I might be able to help you out with that, because dry, it's running right without material in it. That's the way it should run.
Yeah, because when you put the material in, it does that slight hesitation piece.
And you have to hit them both at the same time. You can't hit one and then the other one, and it'll time out. So that's one. Here's another nice one, is you have ram double stop. And the ram double stop is going to stop at the slow speed change point. I'm curious to see if it's going to stop at the automech slow speed change point, but we'll see. No. But if we set the, here, I'll do this. So, set the slow speed here at the same point. And now we'll go back to auto. The double stop is not working. The double stop is not working. So what the double stop does is it stops at the slow speed change point. So if you have a line that you drew on your part and you're not using the back gauge, or you have like a diagonal line you want to hit, you can stop the ram right above the material. Line it up and then hit the pedal a second time and finish
I
it.
think the double step works with this pedal.
Yeah, you can let off halfway.
Oh, yeah, no, I think if you put it in,
What?
yeah, in foot, I think it would do the double step.
Okay, give it a try.
Yeah. And then you go down and do it. Yeah.
So that's a nice little feature. Ram controls like a safety. That really should light this light up. I'll pull the bulb out, and then if you guys want to grab one from Granger, it's cheaper than.
Yeah, most definitely.
We'll charge you. And then these two run the motor on the side here. And when this is pointing to 0, that just means that the ram is level to the bed. And I say that real specifically because these tools can be as much as 1,000ths per foot off.
End up with different things.
Yeah, end to end. So really the best way to level out your ram is to put it in jog.
Put it in jog.
Come down. Too much? You can use a piece as like a feeler gauge. Doesn't have to be a real part.
I think this diagram goes in the middle too. So
Yeah.
it's pretty old.
And see how far we are up here?
Oh, yeah.
And then over here we're touching.
Yeah, and I noticed that in the piece too. One was slightly overbending and one was like at the perfect 90. So yeah.
So now we can bring the ram down a little bit on this side. We're getting closer to 0 now.
Yeah. Okay.
That might be a little bit too much. All right. I can barely get them in on both sides. And
Good to know.
Yeah.
And that way you can level the ram to the tool. And that middle mark just means that this side is level to the ram. If this can be off, your holder, your guide can be off, and your front side can be
So to move that up and down, you pushed
yeah.
the green ones here, right?
Yeah, this does
Ram
this side, that
levels.
one. Yep.
Okay.
Yeah, so the plus will bring that side up, and the minus brings that side down. This side's always fixed.
Yeah,
Okay,
this
this
side-
side's fixed, no adjustment on this side. Okay. All right.
And then the last one, control you have is this is an analog control, but you have a slow or a bend speed control here. So if I run this all the way in, see if it still works. A lot of them are stuck. Oh, it still works. If I run this all the way in, and put you back in auto, go ahead and run that now. It'll run slower. Go even slower. And then we really run it in. And that controls the rate of the bending speed. And the reason you might want to do that is if you had like a 48-inch panel coming out here that was 10 foot, it's going to go wham, wham, yeah.
Right.
So you can bring it up real nice and gradually and then bring it back down.
Okay. That's probably never been used. You know what I mean? It's probably been wide open since day one.
Yeah, if you have it at about half speed, it's also going to help your accuracy because it gives the encoders and the valves a little bit more time to react. The faster you run it, the more your accuracy, or I should say repeatability, part to part to part, is going to vary a little bit.
Yeah, because we always do different things here. And,
Yeah.
you go all the way down to 16 and still.
And on the stiffeners, if the 90-degree perfect 90 on every part isn't that big of a deal, then you can open it up. And then if you get an 88 or a 91 or somewhere in there, and that's okay, and speed and will help you for production, and that's probably better. Or if you get some parts that have to fit together just so, and you want things to be a little more accurate, we'll slow this down, and that'll help your angle accuracy.
Okay.
Yeah, the small frames, those have to be pretty accurate. We got die for that though.
Oh, okay.
Yeah.
16 or 22 millimeter is the Schneider switches in Granger. They'll have this whole array. So all these little toggle switches,
and stuff.
yeah, even the top of this, they're all available. and then the light up ones all have the same light bulb. So this light bulb, this one's out too.
You have a start button?
It should be
That actually went out here recently.
yeah. This one's kind of a bit changed. I'm sorry about that.
Oh, that's all right.
Because it's deeper in there. If you have some SO cable, like some cable like this, strip it back and just use the insulation, and it'll push in there without breaking the bulb. That's me with my needle nose busting bulbs up in the switch and having to take the whole thing apart.
These nuts right here, you tighten them. What he said is either feel this, if it's too hot, loosen them, too cold, we'll tighten them. But they should be warm.
Oh, okay.
Yeah.
And that's like the brake or clutch to keep that ram from falling down, right?
Exactly. So
Okay.
it's got a pretty simple hydraulic system on it. These two valves, all three of these valves are on when you're in fast speed, and then they cut these two valves off, and then this one is only running when you're in the slow bending speed. And the pump's putting out pretty much the same displacement all the time. So when you go through only one valve, it slows it down. So it's a real simple hydraulic system, and then this valve is just either on or off. It's not like a servo valve where it can really finely control the bottom of stroke. So by having some tension on the guideways, it's kind of like driving around with your foot on the brake and the gas at the same time. If you take your foot off the gas, it stops. The car will stop much quicker.
Okay. You
If
want a little
got
bit of drag on it.
Yeah, exactly.
Okay. And you
got
want
it.
those, they should be just a little warm when you're done, or
Yeah, let's
during
try it now,
operation?
and we'll run it up and down about 15 times.
Okay.
See where we're at. Calibrate again. Go ahead and hit the foot pedal. Okay, that's calibrated. And then the auto mech shouldn't have changed because we didn't unplug it. If you don't really have to turn the auto mech off, so you don't have to regulate. If
It's stayed on for the past 10, 15 years.
yeah, if this is the job you're doing for like 2 or 3 days to get through all of that, you can just leave everything on and it should say calibrated. So go ahead and just run a quick, let's run it up and down about 10, 15 times. That's too slow. It sounds a lot, but it's still kind of cold. I'm gonna go bring your height up more. So we'll go, yeah. Height will go 3 inches. And 2 height. And 0.2 height. So now it should come up all the way like to 3 inches to give us a better, more sweep on the guideways. When you get crap on here like this, some brake cleaner, some automotive brake cleaner.
Yeah, we got tons of that stuff.
Just so that it doesn't leave a residue on. Those are designed to run nice and dry and clean.
Okay.
What's the,
Every 100 hours should be checked, right?
Yeah, every 100 hours-ish. And then for the AutoMech, same thing, every 100 hours. Some light fine oil on these spacelets. Looks like somebody had done it at one time.
yeah, right before Brian left, I mean, we were running jobs and he
So
oiled all this kind of
just leave,
stuff.
you know, like that kind of mark on your hands.
We got all the oils and stuff.
Yeah. Just a little bit of lubrication, keep this thing coming. These are really tough packages, so that's nice. And then I'll show you the math on how I adjust this. Physically adjusting it's super easy. We're just going to break these loose and kind of move it back and forth. But I'll show you what the math is. On here, it's not the ideal die to do this with, but we should be able to get away with it. What I want to do is take the whole die thickness. We're at 1.45 and divide that by 2. And that'll give us the center line. I got a calculator. Divided by 2 equals 0.727. So now from the front face of the die to the fingertip, we should be what's on here.
And that's from this front to this front of this tip.
Right. And we should be 1.727. This is why this is not the most ideal die to do it with.
Right, because you don't.
Yeah, it's hard to, really hard maybe this way. Yeah. Yeah, so we're about a 1/2 inch off. Just so. So we're at 1.193. We should be at 1.71 or 27. That's half of the die thickness plus what's on there, and that'll give us the center line.
And that's where the actual.
Yeah, that's where the
down.
actual punch is. So we'll back that up so we get that right. Do both sides. And because Automech is made in Waltham, Massachusetts, everything's standard. Press brake was made in Aberdeen, South Dakota, so everything's standard.
Wow, don't find that much.
Yeah, right. Well, Accupress is the standard for the U.S. military because it's one of the few American manufacturers of machine tools.
Well, Dave probably knew that.
Yeah, there's a couple ships, aircraft carriers that have Accupresses and Accushears on them, and pretty much every major U.S. military base has at least 1 or 2 fab shops. I was just out at Dugway Proving Ground in Utah over the Thanksgiving holiday, and they bought a new Accupress. It's Area 52. That's where all the... Now this thing is so old, can we get it to actually move?
I think I've seen Brian move this before.
He has?
I think so.
It's been a while.
Doesn't look like it's moved.
Might have to actually split this one up.
I got it.
Don't want to whack it too hard to the aluminum.
Yeah, you can see it open up a little bit right there. And I'm off.
Hopefully we can get it to move easily. Still doesn't want to move.
You want some WD-40 or something to get on there?
What's that?
You want some WD-40 to get in there maybe?
Yeah, maybe. See if we can just get it to... Ah, there it goes. I got this end moving. Now that I whacked them.